All right, it looks like it's 11 o'clock. I think we'll get going here. So thank you everyone for attending. Again, this is our TigerStream. This is our first semester doing this. We TigerStream, if you're new to this, is a webinar series to where we're trying to help educate and spread the word of ongoing or past research that's been done with stormwater. And we record all of these sessions and we'll post those to our YouTube website, which is you can just go to youtube.com/@ Auburn Water. And that's where we post all of our recordings. If you missed any of the sessions or if you want to go back and see what we've already done. Otherwise, we do this every month. And if you have anyone that you know that would love to talk on things, and we take suggestions all the time. But again, I'll remind you all at the end of the session. Otherwise, we do not have it is not enabled for you guys to vocally ask your questions. So if you do have a question, just go ahead and put it in that Q&A button at the bottom, and I will be sure to iterate those to Grace, who will be presenting today. Otherwise, yeah, Grace has been a member of our research group. She started this year. She got her master's degree, and this is part of her research that she's doing here. So yeah, I'll let Grace kick it off.
Yes, thank you, Janelle, and thank you everybody for joining. It's a Monday, so we're working into the week. Like she said, I'll be presenting today on part of my research that I did for my master's. So that is utilizing acid mine drainage sludge in reclamation. And so just to kind of jump in to tell you guys a little bit about myself. So I'm from Carmichael, Pennsylvania, and I did receive my master's and my bachelor's degree in civil and environmental engineering at West Virginia University. And then I had a great opportunity to go to the IECA conference in Spokane, Washington, the beginning of this year. And then that is where I got introduced to Dr. Perez and obviously, of course, some of his awesome students, and then eventually got the opportunity to pursue my PhD here. So that's what I'm doing. I am getting my PhD in the Stormwater Research Facility. And yeah, before I jump in, my master's research was two different research topics, so they were very different from each other. So what I'm presenting today, utilizing acid mine drainage sludge, was one topic, and then the other was updating dam design criteria for the state of West Virginia. And so this research project I'm talking to you guys about today, it was previously done or started up by a master's student, and then when he graduated, he passed it down to me. Before getting into the actual research, I wasn't really sure how much of background knowledge everyone had on acid mine drainage or just in general coal mining in West Virginia. So I first kind of want to take y'all back in time. So really, coal was first founded by John Peter Sally, heck of a name, and he founded that in the 1700s of what is today now West Virginia. And so this picture that I have here shown, this is actually the first commercial coal mine that opened near Wheeling, West Virginia in 1810. And so in the 1700s, they were still, when they first founded coal, they were still using trees, and then they eventually shifted to using coal more. But until 1977, there were no rules or regulations set in place to meet environmental and public standards. And so one of the reasons why this is an issue is because you have abandoned mine lands such as this one here still present today. And so this is Hobbit Mine in Lincoln and Boone counties, West Virginia. And it has still not been reclaimed. It is still in existence, and it's been in existence for over 2 decades, which is crazy. And it is one of the biggest mine complexes in the state. So you can imagine how big of an issue. We'll hop into the environmental impacts here soon. But what defines an abandoned mine land as one that you're picturing now? And so the EPA defines an abandoned mine land as lands, waters, and surrounding watersheds where extraction, beneficiation, or processing of ores and minerals has occurred. And so I just kind of want to show you, since there were, again, prior to the Surface Mining Act of 1977, there were no rules or regulations of how to go about coal mining. And so people would coal mine, they would up and leave and move on to the next place. And so you have here, this is a valley. I know it's kind of hard to see. This is where I needed my little laser pointer. There we go. So this is a stream down in this valley. And so as you can see, they were just dumping these coal refuse down on these hills and slopes. And obviously it is not compacted. They did not pay attention to any erosion or any best management practices. And so in the eastern and central parts of the United States, we get pretty heavy rainstorms. So you can imagine all that erosion is just going to go down into your surface waters. And again, we'll hop into those environmental impacts. But this was from the Office of Abandoned Mine Lands and Reclamation for the West Virginia DEP. And on this next slide, they did a reclamation project. So this was of Church Creek. This was an abandoned mine. And then after reclamation, you could see how big of an impact that makes. And so this project cost around $1.2 million. And yeah, so how many abandoned mine lands are in the US today? And so they estimate that there is at least already 140,000 abandoned mine lands and more than 390,000 abandoned mine lands that have not been identified yet. And so that was from the US Department of Agriculture's Forest Service, the Department of Interior's Bureau of Land Management, and the EPA. So that is a lot of abandoned mine lands that have not been accounted for yet. And so the reason why these abandoned mine lands pose a threat to our environment, as you can see in this picture here, this is acid mine drainage, the lovely orange color that you see in this stream here. And so this process can happen naturally. However, it most often occurs due to mining activity. And so how that process happens is you have pyrite, you have your abandoned mine, your mine in the ground, and your pyrite, which is basically fool's gold and sulfide-bearing material. It's exposed to your oxygen. And then from there, you have your water seeping into your mine. And at that point, when you have oxygen and water present with your sulfide-bearing material, this reacts and forms this acidic rich leachate that we're seeing in this photo, this orange stuff. And then from there, you're going to have this drainage and it will eventually end up into our surface waters. And so there are approximately 12,400 miles of streams and rivers that are impacted by acid mine drainage in the United States. So that is a lot of streams and rivers. And finally, getting into the environmental harm. So some of the characteristics that acid mine drainage has a very low pH and it has a very high electrical conductivity. And so due to all the heavy metals that are within it. And so some of those effects are they have a very low pH, and that can affect our aquatic life and our plants, aquatic animals and plants. It can contaminate your drinking water. I found a paper that looked at private well and groundwater quality in West Virginia. This was from 2010, and they stated that 23% of West Virginians get their drinking water from private wells. And so the EPA it does not regulate your private wells, drinking wells, but they do obviously regulate our public drinking sources. And then also, as you could see, it does disrupt the growth and reproduction of the aquatic animals and plants. And then since it does have such high electrical conductivity, it poses a threat to our infrastructure, corrosive effects. And so your bridge abutments, your piers, those are all at risk. Okay, so now I kind of wanted to tell you guys about some environmental disasters that happened in West Virginia. And so kind of give you a little bit of a backstory. The TNT mine, there was a mine in West Virginia, and this was in 1994. They were illegally sealing an underground mine, and it eventually blew out of a hillside, and it released a great amount of acid water into the Cheat River. And it actually lowered the pH of Cheat Lake to 4.5. Crazy. And then, if you think that's crazy, a year later, 1995, the same incident occurred. So another blowout, the same mine, and this actually led to the American Rivers, which is a national river conservation program. It named Cheat River as one of the nation's 10 most endangered rivers, which is it's crazy. And then actually, most recently, I know you're thinking 1994, 1995, that's a little bit a ways ago. And actually, what's pictured here, this is the same mine again. It blew out and it discharged 5 million gallons of acidic water per day into the Cheat River. So this was in March 2021. So that's pretty incredible. And I kind of wanted to throw this in there because even though we did have the Surface Mining Act in 1977 put into place, it just shows you that in the past, these situations are still in the present that we're seeing that is affecting us. This was in 2021, and we are seeing the effects still. So this is a very big issue in West Virginia and other states as well. But I know you're probably like, Grace, this is very depressing. I don't know where you're going with this, but there are different treatment methods. So say this were to happen, we do have treatment methods. Obviously, you don't want it to happen, but getting into those treatment methods, we have passive treatment. And so the West Virginia DEP identifies passive treatment as not requiring as much power as an active treatment system does. So they're using the natural elements to treat the acid mine drainage. And some of those examples could be constructed wetlands, anoxic limestone drains, successive alkalinity producing systems, limestone ponds, and open limestone channels. And so these passive treatment systems are usually designed to have a 20-year lifespan. However, that's very rare to see within a passive system. Most of the time, they see that after 5 or 7 years, you need to have maintenance procedures done, such as dredging it out. And so the NRCS, they recommend dredging at when your sludge occupies half or more of the pond. And just to give you an idea of some cost, so the cost of maintaining a passive system can range from $5,000 to $20,000 annually, but that also depends on how big your treatment facility is or treatment site is, and also some restraints that you have at your site that you need to keep in mind. And then moving on, we also have active treatment system. And so active treatment is like your standard wastewater treatment plant or drinking water treatment. And so this is actually a picture, which I will get to the words on the next slide, but I think this is pretty cool, and I wanted to say it. So this is actually the new Richard Mine AMD treatment plant, and it just began operation in April. This project cost roughly $10 million, and this is right next to a pretty, I would say, pretty large road. It's very busy, and so basically, they opened it up in April, but the West Virginia AWWA student chapter was able to reach out to the West Virginia DEP, and we actually got to go to this treatment facility and have a personal tour. Ooh, sorry. And so, yeah, I actually took this photo, so it's pretty cool, I think. Um, and so for active treatment, obviously it requires your maintenance and power for the facility to function. And what they usually do, they will add chemicals such as limestone, hydrated lime, soda ash, or caustic soda, and that'll raise the pH and will precipitate those heavy metals out. And some examples would just be treatment facilities, or it could be portable equipment. Okay. And so just to kind of give you an idea, again, it depends on your influence, so the acidity and the amount of volume of AMD that you're trying to treat. So every treatment facility is going to be different about how much chemicals they need, but this was just to give you an idea. So one treatment plant was using caustic soda, and they were spending $430 per ton. But to give you an idea, these treatment plants are buying hundreds to thousands of tons per year to treat the AMD. And again, that does have restrictions on your volume and the acidity of your influent that you're treating. And just to kind of talk about maintenance or operating costs. So there are 184 treatment sites for AMD in the state of West Virginia, and those operating costs are about 4 million a year, according to the state's Office of Surface Mining, just to give you guys an idea. And so once you have, after your treatments, either your passive and you have your sludge and you dredge it out, or you have your active treatment, the sludge is settled out, what do they do with that sludge? And so they will pump the sludge into what we have here, or the geobags from TenCot. And so this is specifically engineered material that is very efficient at dewatering and reducing the volume of whatever material you're putting inside here. So they will pump in the AMD, it will dewater, so just the AMD sludge is in these geobags. And so this is kind of where we're coming into the whole point of this research. So what do they do after that? Do these bags just stay here, or how do you dispose of this waste? And so the most common types of ways to dispose of your sludge is they will either pump it back down deep into a mine, they will put it into a retention pond, or you can bury it on site in a landfill. And so the issue with that is the cost associated with disposing of the sludge is very high. And so that's why the DEP wants to look at, can we use this sludge, a waste byproduct, to see if it has any beneficial or economical use. So finally, I know you guys are like, oh my gosh, get to your research. But the objective of this research was to evaluate the use of that AMD sludge within those geobags as a soil amendment to support vegetation establishment and persistence. So again, the West Virginia DEP is trying to find other ways to utilize this waste byproduct. And so there are, there's a lot of research that has been done with AMD. It has been an issue for quite some time now, but I kind of wanted to just give you an idea of some research that has been done. And so they used the sludge, the AMD sludge, as a soil or as an oxygen barrier for the acid generating tailings. They did that through lab and field tests, and they found that it effectively prevented AMD generation, and it showed a promise as a barrier. There also was using AMD sludge as a soil substitute for reclaiming abandoned mine lands. They did this research in pot experiments and looked at 3 different plants. They also used chicken manure. They didn't see any removal of heavy metals. They stayed the same, but the plants did survive. And then this is the study before from the master's student. So using AMD sludge as a soil amendment in a small scale growth study with different various volumetric ratios with topsoil. They were mostly focused on how tall these stems were growing for the biomass of the plant. And then lastly, a lot of emerging research. It has been, but it's kind of becoming more of the hot topic. It's focused on recovering heavy metals from the AMD sludge for reuse. And so they used coal fly ash and natural clinker, and it removed iron, zinc, and copper. And then they also looked at double oxidized carbon nanotubes, and it removed copper, manganese, and zinc. So some pretty cool stuff, and it's nice to see and interesting to see the different thought processes and ideas of how to solve this solution. So now actually jumping into my research. So here we have the study location, and what we did was a growth study plot that was created in Monongalia County, West Virginia. And so this site was used primarily because it is located. Let me get my laser pointer out again. It is located on top of the hill crest, and they kind of dug this out. So it's a large pit. This is storing geobags, the picture that you saw, and so it can contain the runoff. So the DEP was fine with us doing our growth study plot here. And also, since the geobags were stored here, it allowed us for easy access to that material. Okay. Now going into how we actually created these. So these plots, again, another master student started and then I took over. So these plots were originally created at the end of September in 2022. And there are 5 different treatments and 3 replications of each treatment. So my study was from the end of May to the end of October. And so the sludge that we used here was produced at a treatment site located in Preston County, West Virginia. And so, like I was saying, those treatments are listed here. We had 5 different treatments and 3 repetitions of each treatment. So we had our 100% topsoil acting as our control. We had 25% AMD sludge, 75% topsoil, 50% AMD sludge, 50% topsoil, and 75% AMD sludge and 25% topsoil. And then we had our 100% AMD sludge. And so here's just to give you a picture. So the whole growth study plot was 15 feet wide by 25 feet long, each plot being 5 feet by 5 feet. And yeah, so after we made the different, all the plots with their different volume ratios of AMD sludge and topsoil, we then seeded per the West Virginia DEP seeding guidelines, and then we also fertilized and strawed. And here is the seed mixture that we used. Okay, so now looking at our data collection. So we monitored data from the end of May to the end of October. And so we were going out every 2 weeks to collect data. So we collected temperature, electrical conductivity, and soil moisture using the Field Scout TDR 150. Basically, it has 2-inch probes, and you could stick it into each of your plot, read, it spits out those values for you. And so at each plot, we were doing 5 random readings per each treatment. And then This is how we measured ground cover. So it was a 1 meter by 1 meter PVC square, and it just had laced through it string. So at each of these crosshairs, there was 100 of them. And so when you would place it over each of your plots, you would determine if there was grass or straw or bare, and that's how we got the grass coverage. And then we also, at the end of our study, so in October, we collected biomass samples using this 1 foot by 1 foot PVC square, and we randomly placed it over each plot, collect our biomass samples, and weighed them. And then what is not pictured, at the end, we took soil samples of each plot besides the 100% AMD sludge, which I will talk about later. And then we sent that to a laboratory to do a saturated media extract report. Okay. And then what did I do with that data? I basically, if I could get there. Maybe. All right, so I did statistical analysis with that data that we collected, and I did that in RStudio. So I did a one-way Kruskal-Wallis test with an alpha value of 0.05. And then from there, if we got a return p-value that was less than 0.05, we continued with the Dunn's test for a pairwise comparison so we could see what was statistically significant from each other. And so finally getting into some results here. So this is for our ground cover, and this plot here is just showing you the overall duration of our study period and how each treatment performed. And so the one thing I want to note, the West Virginia DEP requires you to get to 70% coverage, ground coverage, and then your temporary erosion control devices can be removed. I don't know if that's the case for other states, but for the West Virginia DEP, they strive for 70%. And so as you can see, some of our treatments did reach that 70%. However, looking at our 100% AMD treatment, it did not do too well with the ground cover. And I kind of want to explain that. So it has a very high water content. And so since we placed our plots on the surface, I think that the plots for 100% AMD eroded a lot more than our other treatments. And I think that's why there's not a lot of ground cover. But let's see if it was statistically significant. And so you can see the 25 AMD and 50 AMD are pretty similar. Our topsoil treatment obviously performed the best. And then looking at our AMD treatment, it was significantly different than our other treatments. Now going into volumetric water content. So again, kind of going over the whole duration of the study. Our 100% AMD treatment was the highest throughout the study duration, and that was not a surprise because AMD sludge has a very high water content. It's at like 98%, and so seeing those results was not a huge surprise. And comparing all of our treatments in the statistical analysis, we can see that our 100% AMD treatment was significantly higher than our other treatments. And looking at electrical conductivity, you can kind of see AMD did have pretty high at first, and then everything kind of dwindled down to around the same. AMD does have very high electrical conductivity due to its heavy metals concentration. But what I thought was interesting is that there was no significant differences among any of the treatments for conductivity. So that was interesting. And then temperature, we wanted to see, since the AMD sludge has a very high water content, we were interested to see if the temperature of the sludge would react differently with the plots. And so over time, there was little to no difference between any of the plots' temperature and then finally looking at that statistical significance, there was they were all pretty much the same. And biomass. So we collected biomass samples. And again, how I said that the biomass samples I thought were going to be statistically significant for our AMD treatments due to how much erosion occurred. But to my surprise, there actually wasn't any difference among the different treatments, even though you could see it is a lot lower than the other ones. And then for our soil sample, so I know this table's a lot. We'll go through it. So basically, we took soil samples from each of our treatments besides the AMD, 100% AMD treatment due to there was not enough soil to be sent to the laboratory. And so we sent our soil samples to A&L Great Lakes Laboratory, and they did a saturated media extract report, and they used the NCR 13 number 221 1998 method. And so these were those results that they got back with us. And so some of the ones I kind of want to point out in topsoil, they do add some of these like calcium, magnesium, but what I thought was interesting is that in your AMD sludge, you usually have these higher concentrations of calcium and magnesium. However, we saw the higher concentrations for calcium, magnesium, iron, and also manganese was all the highest within our topsoil treatment. And I thought it was going to be actually the opposite. I thought our higher AMD sludge were going to have the highest concentration. And then your pH, even though AMD sludge has, or your AMD has a very low pH, when they dose it in the treatment plant, it raises the pH. And so that's why your sludge, you're not noticing any low pH. And then for our sludge characterization, so this is pretty important. They did one test whenever the previous master's student was using the sludge, and then they conducted another test for the sludge characterization. And so the results are pretty crazy. So in test one, you can see, so I guess I should say these values. So the only value that's outlined in red is the lead value. It is actual measured concentrations. And then all these other values in the table, though, are reported as half the detection limit. And so obviously your lead level in your first test is, it's insane. But then you go from 1,000 down to 4. So it just shows you the reason behind that is when one treatment plant can have multiple mine discharges that they're treating. And so each treatment plant, whenever they're treating it and then they're pumping that sludge into a geobag, that could have 5 mine discharges in one geobag. But let's look at the regulatory limits in maximum leachable concentrations. And so this regulatory limit is from the Code of Federal Regulations and 268.4. And so obviously you could see that the lead is completely over that. So those are those regulatory limits. And then this maximum leachable concentration, these values actually came from Kansas State University. They partnered up with the Department of Health and Environment and got these values. And so basically, yeah. Okay, and then jumping into kind of the key findings that we saw. So the AMD treatment for our ground cover had the lowest mean ground cover compared to the treatments throughout the study, and it was significant. When looking at our soil moisture, the mean soil moisture in AMD was significantly higher than the other treatments, which again wasn't a surprise. And then electrical conductivity, although AMD has a high electrical conductivity, and it did have the highest, it did not show any statistical significance among the other treatments. For biomass, AMD treatment did have the lowest biomass, but again, it was not significantly different from the other treatments, which was a surprise. And then looking at our heavy metals, the sludge characterization, the AMD sludge contains high levels of iron, copper, manganese, and zinc. The highest concentrations that we found were detected actually in our topsoil treatment. And so future recommendations, we met with the DEP after, and they were kind of interested in expanding it even further and trying to look at other seed mixtures, using different plants such as trees. And one of the ideas was, since the AMD sludge has such high water content, what if we dry it first and then apply it dry? Looking at water runoff quality. So you guys saw the maximum leachable concentrations. And so basically looking at the water quality from runoff would be interesting to see, because I know you guys are probably like, okay, you got it out of the water and you have it, why not dispose of it? Why are you land applying it? And I completely understand that. It in its AMD in its aqueous form poses a higher threat than it being in its solid form. Then placing fencing around the plots. I cannot tell you how many times we showed up. There were so many deer that were using the AMD, like our plots, as bedding. I I guess that's West Virginia, but they loved it. There were so many frogs and insects that loved the AMD, and I was like, it was interesting. So definitely put fencing around the plots in the future. And then lastly, we placed these plots on the surface, and really the area that we were interested in doing it had a very rough terrain, and that's also why the DEP was interested in having these plots here. Just like a lot of your abandoned mine lands, you really don't have any soft spots. And so we should have dug it and put it into the ground than rather on the surface. And yeah, I think overall, I know looking at the sludge characteristics, you can see that there is a lot of variability within one geobag. And I think if you were to use this as a land application in the future, I think that you would have to do your research on what treatment plant you would be using that sludge from. So here is the beginning of our study, and here is the end. So they did pretty well. And so I think going with your lower 25% AMD sludge and 75% did very well. And again, I think it goes back to looking at different treatment sites and if they can be land applied or not, looking at that sludge characterization and seeing if those fit the standards to be land applied. And I guess going off of that, this is actually the cool stuff. I'm sure somebody will have questions about this. And so kind of like how I mentioned at the beginning, rare earth metal extraction or heavy metal extraction is becoming a very big thing at WVU. And so they have a treatment plant. It was up and running in 2018, and the goal was specifically for this rare earth extraction. And so they actually just got, in 2023, they got $8 million. And so that is going towards designing, construction, and operating of a pre-commercial demonstration facility for separating and refining rare earth elements. So this has been a very big hot topic. A lot of grad students are focusing on portable treatment that you could take to these different sites. And it's pretty exciting to see, because I know when you talk about these environmental issues that we have, they can be pretty depressing, and it's hard to find solutions. And so seeing one that actually environmental and will be economically beneficial to us is awesome. And so I know the research that I showed you guys today definitely wasn't a game changer like this one is, but it is always nice to see that we're keep making these steps forward. We all have the same goal in mind, and that is to fix this issue. And not only we get so many of our rare earth metals from China, and so this is going to be. I have a very good feeling about this, and it's very exciting for WVU. So with that being said, thank you so much. I know this was definitely not stormwater related, so I hope that you guys were interested. And yeah, if you have any questions, please do not hesitate, and I really appreciate it. So thank you guys. And then here's my references. Back to that.
Thank you so much, Grace, for presenting. I wouldn't say that this is not stormwater as your acid mine drainage is coming in, and it's still impacting our drinking water and whatnot. So that still kind of ties everything in a pretty bow.
Yeah.
But we do have a question in here, and someone had asked what the particle size distribution looked like across the media treatments.
The different treatments.
The
That is a
particle
great
size,
question.
yeah.
Are they specifically looking at the AMD or just every treatment doing different particle sizes? I guess it would be every treatment.
I'm gonna guess every treatment.
We did not do any particle size distribution. Technically, I know someone that did do or tried to do a particle size distribution on AMD sludge, and technically it's not classified as a soil, so it's hard to classify it, use something that is meant to be for soils and then classify that. But we did not do any particle size distribution. That would be interesting to see among the treatments.
If anyone else has any other questions, we'll give you a minute to throw those in there.
Yeah.
I guess I have a question for you.
Mhm.
In the meantime, since you had your beds raised up off the ground a little bit, and you mentioned that the AMD retains a lot of water, do you think that that helped your plants at all or affected your results?
Yeah, that's actually why kind of at the end. So you basically have to have more, you for something to be land applied, it has to have like more than one benefit. So having that AMD already have like such a high water content, it was already kind of like, okay, you are going to be benefiting the plants because of this high water content. So I do think it did affect results, but that's why one person from the DEP was mentioning, why don't we try drying this out first and then applying it to see how it works. So I definitely think it would be interesting to see if there is any difference, but I would assume so since it does have a very high water content.
We have another individual who put in the chat here. Here in Southern Company, we are working on rare earth extraction at one of our facilities. So we'd love to hear about the package system that you spoke of previously.
Yeah, everyone's so interested on that. I know it's cool. It is actually patented, and so basically, I can't speak on behalf of it. I could always share some contacts that I have. Basically, that $8 million that was granted for the rare earth element extraction, that's kind of what they're putting it towards. Everything of that whole design process has been patented. I know that they dose it at certain pHs and metals will fall out. But I could definitely put you in contact with people that would know more and could know more of what to say and not what to say because I really can't take my word for it here. But yeah.
Do you have an email that we could throw in the chat?
Yeah, I definitely can. Do you want to type, or I guess I could type it in the chat here. If anybody's interested, please reach out to me. This is my email for whatchamacallit here at Auburn. Oh, I don't know if I could see that. Host and panelist. Uh, Janelle, I put it in that. I don't know if anybody else can see it, the webinar chat, but
Let me
yeah.
let me see if I can get this to the individuals. In the meantime, while I'm trying to get that out.
Great.
There's another individual that said, I may have missed this, but is there a concern with hazardous materials leaching from the dried sludge in the future? And with that, is the disposal area lined similar to like a landfill?
Yeah, it is. And it's basically like a landfill. But the cost with that is pretty high. It basically is you would treat it as a hazardous waste. But that's kind of like how I was saying, I think with every different treatment plant, you're getting discharges from so many other mines. And so I think if you were to go with the route of land applying, you would definitely need to look back at different mine discharges and different treatment plants, what their sludge looks like, because not every sludge bag is going to be the same. So there are leaching concerns in the aspect if you would land apply it, but whenever they do put it in a landfill, it is treated as a hazardous waste, and therefore it does have a liner in the bottom.
Perfect. I'm not seeing how I can get your email on there. Since you're sharing your PowerPoint, you could just edit that one screen really quick and throw it on your screen, maybe if you hop out of presentation mode. It might be a little easier than verbally trying to tell people.
Yeah, I know you're fine. Thank you. There we go. So yeah, if you guys have any questions, please don't hesitate to reach out. Do we have more questions or?
I think that's it.
Okay, sweet. Thank you guys so much. I appreciate taking the time out of your day to be here. Um, and yeah, I hope you all enjoyed it. So thank you so much. I appreciate it.
Yeah, thank you so much, Grace, for presenting. We're
Yeah.
excited. Again, thank you everyone for attending. We really appreciate it. As you can see, we don't exclusively talk about the research that's done at our Auburn Stormwater testing facility here. So we do like to kind of branch out and bring everything together that it's all affecting stormwater. So we all can bring in all the different disciplines with that. So if you have anyone that has a topic that can relate to that, or you'd like to share some materials, or know anyone that has a topic that would be really informational to put out here, we'd love to hear that. Please send us an email, and we will get you on the list for that. But yeah, if you had a question that pops into your head after, please again reach out to us and we'll put you in contact with Grace and we'll get that answered. Otherwise, if you had to hop in a little late and you wanted to see the beginning or any other previous presentations that we've done, you can go to our YouTube page where all these recordings are posted at YouTube/ at Auburn Stormwater. But otherwise, if you have any PDH hours, we'll send out an automated email so that you can um, get those credits for you. Otherwise, a little sneak peek for next month. I'm the presenter, so I will be talking about one of my master's projects, and the topic will be on understanding and improving the hydraulic performance of wattles for erosion and sediment control. So we'll hop back into some work that we've done here at our testing facility, and yeah, keep an eye out for that email. Otherwise, thank you again for attending. Have a good one.
Thank you.
Thanks, Grace.
I don't think I can leave.